Good evening, everybody. Welcome to Chem 170 with your host, me, Dr. White. Tonight, I'm going to do the review for test number one. How do you like those special effects? For test number one. And what's on test number one? Let's take a quick look. And if you look on D2L, you'll see I posted on the 2nd of this February that on this Thursday, the 6th, I will give test number one online. You'll download a password protected PDF file from the assignment area D2L. On Thursday morning, 8 a.m. or earlier, probably earlier, but anyways, at least for sure by 8 a.m., I will send out the password via email and also put an announcement on D2L for test number one PDF file. Now, you'll have until Friday, the 7th at 8 p.m. to finish taking test number one and upload your test number one answers to the assignment area of D2L. This is important as a single PDF file. I do not want a bunch of picture files. Please, makes my life hard. It's hard enough as it is now. So please help me out on that. It should take you, if we are face to face, my tests are designed, if you've done the practice problems and studied, normally students, if we were face to face, have 55 minutes. Just about everybody's done in 40 minutes. But since we don't have to get out of a classroom for the next class, take as long as you need. But make sure you have it uploaded by the deadline on Friday. Now, test number one has 10 pages, 14 problems. Some of the problem are multiple part. I have never and will never give a multiple choice question in Chem 170. Won't do it. Haven't. I've been teaching it since 207. Boy, that's a long time. But anyways, and I've never given a multiple choice question. I won't. Now, test number one covers alkanes, cycloalkanes, alkenes, that's double bonds, alkynes, that's triple bonds, and aromatic compounds. Now, the point breakdown is 13 points general knowledge and 45 points nomenclature. What's the nomenclature question? Two types. One is, here's the structure, give the IUPAC name for it. And if you've been watching the videos, you know IUPAC means the official name. I'll never ask you what does IUPAC stand for, even though I like to say International Union of Pure Applied Chemistry because it sounds cool. Now you know I'm an organic chemist. All right. The other type of nomenclature, here is the IUPAC name or the common name, draw the structure. All right. Next will be 47 points reactions. There's mainly one type of problem, and that is give the organic product or products for the following reaction. There will be what I call a synthesis problem, only one. See how nice Dr. White is? These are harder. That is give the starting materials that would make this product. And I did that. If you notice, it adds up to 105. There's five bonus points. Now, students will take the test and say, which one was the bonus question? I don't do that. I just have the whole thing add up to 105. You pick what's the 5 points for bonus. Doesn't. All right. This will not be an open note test or internet and all that. And I'll be very honest with you. I put things in my test that catch students who cheat. And I've been doing this online for 4 years. I've been doing it in face-to-face longer, and it works. Please don't cheat. All right. If you have any questions while you're taking test number one, remember my class, there's no such thing as a dumb question. That applies also while you're taking a test. And therefore, email me. I'll be checking my email approximately every 2 hours on Thursday, maybe 3, if something comes up where I have to leave or something, but frequently. And I'll do that from 8 a.m. until 8 p.m. And on most of Friday, I'll do the same thing. All right. As you know, tonight I'm doing the review, so I don't have to go through that. Now, one important thing, and let me show you this, but I'll read it. I'm going to be working from test number 1 review file, and this is in the lecture folder of D2L. Now, D2L is an ancient software program. I mean, it's old. They haven't updated certain things they should have. To see this file, you probably have to click the Load More button at the bottom of the lecture folder screen in D2L. Let's take a look and see if I go to Student View, Content, Lectures. And if we scroll down, notice here it has 36 topics. And if you go to the very bottom, I haven't seen that review file. And right here, everybody see the Load More button? I'm going to click on that. Oh, there's more stuff. And there's where test number 1 review is. I have it both as a Word document and a PDF file. So don't forget, if you don't see something in a folder that I tell you is there, click on the Load More button if it's there. All right. And that's just gives you an idea what is on test number 1. All right. Oh, one other thing. If you don't have a printer, and some of you may not or have access to a printer, just take a plain piece of paper. You can do the lined or unlined. I don't care as long as I can read it, and write the question number and your answer. You do not have to write the question. That's a lot of work. Wow. So you don't have to. Just write the answer. Dr. White has a photographic memory, so I can just say, oh, I know that problems, and I do. Sometimes it's not a good thing because you don't forget things that you'd like to forget. All right, let's get going. And these are things you should know for test number 1. Now, before I start this, the best way to get ready for test number 1, you should have watched the videos. 2, do the practice problems for alkanes, the practice problems for alkenes and alkynes, and the practice problems for aromatic compounds. One thing or 2 things I should talk about my tests. Actually, 3 things. I'll get the number right eventually. But anyways, first, I give tests by my golden rule of teaching. That means I don't do to my students what I didn't like done to me. I don't. And I still remember when I was a student long ago. All right, number 2, everything on my test, every question, I will have covered the concept behind that question at least twice, probably more, in the videos, or like I call them, my lectures. Again, every concept behind every question on every test and the final 2, I'll cover at least twice, a lot of more times, in the videos for this class, meaning my lectures. And finally, you should have plenty of time to finish if we were face-to-face. Again, doing my golden rule, when I was a student, I was usually, some classes, the only one who could finish the test and the others didn't. That's not right. All students have, if they've studied, finished my test early. All right, let's get going. All right, started out the semester, hydrocarbon. You should know a hydrocarbon is a molecule with only carbon and hydrogen atoms. Remember, this file is available in D2L. Don't forget to click on the Load More to see it. It's cleverly named Test Number 1 Review. All right, next, saturated hydrocarbon. Well, hydrocarbon is a molecule with only carbon and hydrogen atoms, but a saturated hydrocarbon in which all carbon-carbon bonds are single bonds. Unsaturated, which you should know, hydrocarbon. It's a hydrocarbon, so that means it's a molecule with only carbon and hydrogen atoms, but it's unsaturated, so that tells you it contains one or more carbon-carbon multiple bonds, or another way of saying that, one or more carbon-carbon double or triple bond. All right, now I'm not going to ask about it, but you should know, I won't ask. Alkanes are acyclic, that means not in a ring, saturated hydrocarbons. I just noticed for cycloalkanes, I have an A in front of the cyclic. It should be cyclic saturated hydrocarbons. Now, you should know how to draw alkanes and cycloalkanes. And for this, one of the most important things you should remember for test 1, 2, 3, 4, and the final is there's always 4 bonds to carbon. I gotta get this finger fixed. 4 bonds to carbon. Ooh, same thing on this hand. I gotta get it fixed. 4 bonds to carbon. Remember that. There's 4. I can even do this with my eyes closed. 4 bonds to carbon. Anytime you write down a structure, make sure there's only 4 bonds to carbon. 70% of what I grade. When it's wrong, 70%, if a student had just looked and said, ooh, there's 3 bonds to carbon, that's got to be wrong. One time somebody had 7 bonds to carbon. It took me a long time to stop laughing. It was wrong. That was my red pen crossing it on a piece of paper. All right. And let's do something real quick, not real quick. For alkanes, if you were to draw this structure, you have to put in the hydrogens. There's 4 bonds to carbon. This first one has 1 bond. Math is real hard in my class. 4 minus 1 equals 3. So it has 3 hydrogens. This carbon has 3 bonds. The line is, remember, a bond is 2 electrons, each bond or line. Remember, each line is a pair of electrons. This has 3 bonds. 4 minus 3, 1. So there's 1 hydrogen here. This has 1 bond, so 4 minus 3, 3. Same thing here. Now, this carbon has 2 bonds to it. Well, there's always 4 bonds to carbon. 4 minus 2 equals 2. So, and that's how you draw the structure. And you should know how to do that. For rings, cycloalkanes, we use the polygon shape. For a 5-membered ring, it looks like this. We don't show hydrogens. Every bend in a line is a carbon. So 1, 2, 3, 4, 5. For 6 carbons is a hexagon, or as I like to call it, cyclohexane. 1, 2, 3, 4, 5, 6. No, that's not a square. It's cyclobutane. 1, 2, 3, 4. And let's do one more. A triangle. No, it's cyclopropane. And that's how you draw. There are other ones, but you're not going to encounter that in my class. In fact, most of the time, I never encountered it in all the decades I've been working in the chemical industry. I shouldn't have said decades. Anyways, you should know how to do that. Now, IUPAC are the nomenclature rules, and you should know how to do that. You should be able to first find the longest chain in a carbon, whether it's a molecule, whether it's acyclic or cyclic. And if you look at the practice for alkanes, I have some examples. And it doesn't have to be straight across only. If you look at F, the longest chain zigzags. See where I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, sometimes it will just be straight across. That's the longest chain. Like in C here, the longest chain is 6 across. This would be 1, 2, 3, 4, or 1, 2, 3, 4. And the longest chain gives you the root name. And hopefully you did these problems. Now, you should know the alkane names 1 through 10. Methane is 1, pentane 5, hexane 6, octane 8, decane 10, all those. And we went through that, I did in the videos. Now, once you find the longest chain, any other carbons or on anything on a ring are called the alkyl groups. CH3 attached to anything, oh, look, it's your old friend, the methyl group. Mine too. 2 carbons is ethyl. There's 3 carbons, 2 choices. When the N carbon is this line bonded to whatever your longest chain or ring is, that's called N-propyl. And when there are 3 carbons and the center carbon is bonded to the longest chain or a ring, that's isopropyl. And Dr. White loves isopropyl groups. They've been good to me. I've been good to them. Next, and also the other ones, ethyl and methyl, but I have a special place in my heart for isopropyl. Next, you have butyl, 4 carbons, and there's actually 3, but the third one in the last many decades, I've only seen it once. So I'm not going to teach you because odds are you'll never see it. But 4 carbons and the N carbon attached to a chain or a ring is N-butyl. 4 carbons, 3 carbons attached to the center carbon, and the center carbon attached to something like a ring or a chain, that's tert-butyl. And about by now in the videos, I'm being a lazy organic chemist, I call it T-butyl. You can put down either way. And you should know these. Hint. Now, when I talk about IUPAC names, if you look at E, you find the longest chain, 1, 2, 3, 4 carbons, and that's butane. Then we have left over here CH3. Oh, it's your old friend, the methyl group. And so it's methylbutane. Now, you always start for a chain from the ends, not anywhere else. That's a common mistake students make. So don't make it, please. And therefore, for this one, if I start on this way, 1, 2. If I start the other end, it'd be 1, 2, 3. And you always give substituents the lowest numbers. So that would be 2-methylbutane. Now, if you look at D, it's the same thing. That's because, like my hand, molecules can rotate. And that's what I did there. Now, if you have more, like here, 9 carbons longest chain, I have a methyl group, and an isopropyl group. If we start numbering here, the methyl is on 2, the isopropyl is on 4. Now, IUPAC has an alphabet rule, which is the substituent with the highest priority in the alphabet, meaning closest to the front, goes first. I am not holding you to that. So for G, the correct answer is what I have. If you put down 4-isopropyl 2-methyl, no name, I would mark that correct also. Don't tell the IUPAC police. All right, now this is very important. A common mistake on test number 1 Here we have a ring. How many carbons in the ring? Count the bends. 1, 2, 3, 4, 5, 6. You name that like you would an alkane, hexane. But because it's a ring, you need the prefix cyclo. Cyclo tells you it's a ring, so it's cyclohexane. If you were to just put down hexane and coming to me and say, oh, Dr. White, why didn't I get any credit, partial credit? I say, because it's all wrong. You need the cyclo. So remember that. For rings, you have the name of the alkane name, but you need the prefix, the thing that goes in front, cyclo. On a ring, when there's only one substituent, it's always going to be carbon 1. It has to be. Everybody knows that. Since everybody knows that, and organic chemists are lazy, the IUPAC rules are you don't put a number 1 there. So that's 6-membered ring, cyclohexane, 3 carbons centered to the ring, isopropyl. That'd be isopropyl cyclohexane. If you put a number down there, 1 isopropyl, so I will take off points because it's wrong. And like I said, the other type is draw the structure. Here, you start from the right and move left. I like those special effects. And pentane, 5 carbons. On carbon 2, methyl right here. You could have put the methyl on this side too, starting, but most you won't. And it's on carbon 2. Now, word to advice to you. When you're drawing structures, leave the hydrogens till last. When you're drawing structures, it's easier. Leave the hydrogen to last. All right, now I said on beginning on test 1, I think there'll be 13 real world or general knowledge questions. Well, general knowledge question could be, give an example of an alkane in your daily life. And there it is, natural gas, the propane for your barbecue, BBQ is shorthand, gasoline, Vaseline, baby oil, candles, all have alkanes in them. How many of you drove by a gas station and thought about, wow, there's alkanes in that stuff they're selling? That's a good thing. All right, now I only asked you to learn one reaction, and that's combustion. If you take an alkane or a cycloalkane, react it with oxygen, you get carbon dioxide, water, carbon dioxide, CO2, water, H2O, heat. Now, in my class 1, I'm not interested in heat. If it gives it off or not, I'm not interested. The other thing is, unless you're doing charge weights, how much of this and that you have to put together, which we do not do in this class, you never have to balance an equation. Only write down the structures of the product. So if we go to the problem set, give the reaction products for the following. Now I won't do B or parentheses, but A, propane. Oh, it's an alkane, oxygen. I know I get CO2 and water. Oh, cyclohexane plus oxygen. That's a cycloalkane plus oxygen, gives me CO2 and water. Now, the big, how should I say it? The standard trick organic chemists instructors do on a test is they give a big, scary molecule. Ooh. But if you know what it is, can identify it, it's not big and scary, it's just big. So if I were to do the following, give the organic, or give all the products for the following. Remember, there's always 4 bonds to carbon, which is why I'm putting in the hydrogens. If I were to say, give the products for this, well, this is an alkane. It's reacting with oxygen. I know the general reaction will give me CO2 plus water. Therefore, my answer is CO2 plus water. Now, notice I wrote the general reaction, and I've done that the whole semester. You'll see I always do that. That's to help you learn it. Now, listen carefully. Some of the top students I've ever had, and I've been teaching Chem 170 for a long time, every reaction like this, they put the general reaction underneath. Every one, the top students. Also, some of the top students I've ever had in Chem 170, they never write it underneath. Whatever works for you, do it. But be sure to write the answer like here, CO2 and water. And that's the alkanes chapter. Now, alkenes and alkynes. An alkene is a double bond, and we show that by two lines. Remember, each line is a pair of electrons. You should know a double bond contains one sigma bond. That's what this is, the Greek letter sigma, and one pi bond. Excuse me. Alkyne, that's a triple bond. And here, you should know a triple bond is made up of one sigma bond and two pi bonds. Let me say it again. One sigma bond and two pi bonds. Now, pi bonds I can break like that, and they're fun to do that. You learned that in this chapter. All right, nomenclature. And here I have an oops mistake. That should be YNE right there. I'll try and correct it. And for a double bond, you find the longest chain with the double bond in it. If it's acyclic, first of all, you name it as an alkane, drop the A and E ending, put ENE. And you have to look if it's cis or trans. If it's in a ring, cycloalkene, no number or cis or trans in this class and everything I've ever worked for, it's always going to be cis, which is why there are some examples that are very rare. People have made trans, but that's rare and you're not going to encounter it ever. I never did, other than reading an article in a journal years ago. Now, if we look at C here, we've got a double bond. Now, one of the things you should be doing with alkenes, alkynes, and aromatic compounds, look at a molecule, look for what's not a carbon-carbon single bond or a hydrogen or carbon or hydrogen. That's where the fun is. Again, when you look at a molecule, I do, look for what's not a carbon or hydrogen atom. And this chapters, you don't have that, but what's not a carbon-carbon single bond? Because that's where, and hopefully you'll hear this, the fun is. And here we have a double bond. How many carbons is the longest chain? 1, 2, 3. Even though it bends up, they're connected together. 3, 4, 5. Pentane, but it's a double bond. Drop the ANE, ENE. Which carbon is the carbon of the double bond closest to the end of the chain? 1, 2, or 1, 2, 3. Take the lower number. Then you have cis and trans. Cis, the hydrogens, and for this class it would be hydrogens. You can have other groups like halogens or other things, but I'm sticking to hydrogen. When they're on the same side as the plane, of the double bond, that's cis opposite trans. When you have a ring, it's going to be always cis, find the longest chain. No, find a ring. 5 carbons, pentane. It's double bond pentene. It's a ring, cyclopentene. Now, always in a ring when there are no other functional groups in this test, that will be true. One of the carbons of the double bond has to be 1, the other 2. And you number in such a way that the substituents get the lowest numbers too. And the only way this will work for E, this is carbon 1, 2, and the T-butyl group. Oh, my favorite, a T-butyl group, is on carbon 3. We said this was 1, 2, 3, 4, 5. That's a lot higher than 3. Remember, you have to know how to add and subtract up to 4 and what numbers from 1 to 10 are smaller and larger than the others. And that's how you do it. And here, the other type of nomenclature, here's the name, draw the structure. Start from the end on the right, move this way. ENE ending, double bond. That were ANE, 8 carbons. The double bond starts at carbon 3, 1, 2, 3. It's trans, so the hydrogens on 3 and 4 are on opposite sides of, if I could put my hand there, right here. And then 5, 6, 7, 8. And here, methyl, CH3. Remember, di means 2, tri means 3. There are 2 methyl groups that are on carbons 5 and 6. Now I'm going to jump down for a second. Now, triple bonds, same thing, but now you find the longest chain with both carbons of the triple bond, and then you name it, drop the ANE ending for the longest chain, put YNE, the carbon of the triple bond closest to the end of a ring is given a number, or end of the chain is given a number. Now, in my experience, I've never seen a triple bond in our daily life in a ring, so I'm not going to ever give it to you. And you cannot have cis or trans in a triple bond. Now, reactions, here are the general reactions. And this means any molecule with a double bond in it, if I add hydrogen to catalyst, CA2 is short for catalyst, that can be nickel, platinum, or palladium. I break the pi bond, and each carbon of the double bond gets a hydrogen. Now, earlier I said for test 1, you should know, and it's your friend, know there's 4 bonds to carbon. The other thing that's your big friend on test 1, 2, 3, 4 in the final, do you break carbon-carbon single bonds? Except for combustion, which we just did, the answer is no, don't, please, it's going to be wrong. So remember, you don't break carbon-carbon single bonds except for combustion. So what does that mean? If I were to ask you, draw the structure, and that means draw it, don't give the empirical formula, which is number of carbon, hydrogen, oxygen, if there is any. In this chapter, there isn't. If I were to ask you, draw the structure of this, how do you do this problem? Well, you look for what's different. Ooh, a double bond. We're adding hydrogen, and what's this? Nickel. It's a catalyst. Remember, the catalyst can be nickel, platinum, or palladium. and you break the pi bond. Remember, there's one pi bond and one sigma bond. Single bond, you don't break a sigma bond. They're very hard to. Pi bonds, fun to break. And each carbon of the double bond gets a hydrogen. Now, do you break carbon-carbon single bonds? No. So notice I have 1, 2, 3, 4 carbons. This is not meant to how you IUPAC name it, but they're 4 carbons. So I'm going to end up with 4 carbons. Now, what does change is the double bond here is broken, and each carbon of these 2 carbons gets a hydrogen. And now I know there are 4 bonds to carbon, so I can put in the rest of the hydrogens. Now, one thing, do you notice this carbon here, right here, has a hydrogen here and a hydrogen there? You could have written it this way. And this N carbon here, 2 plus 1, you could have written it this way. Now, for my class, and that's the ugly looking 3, that's better. You can write it this way. It's an extra step to condense, bring the hydrogens together where you can make a mistake. So Dr. White's going to be nice and say, you don't have to do it. But remember, you don't break carbon-carbon single bonds. Now, X in organic chemistry means the halogens, fluorine, chlorine, bromine, or iodine. You have a double bond at halogen gas, because that's how it exists in nature. You break the pi bond, each carbon of double bond gets a halogen. You don't break carbon-carbon single bonds. All right, moving on. Now, the first 2 were symmetrical addition. You're adding the same thing to both carbons. What happens if it's different? And that's where we have this case, HX, where X can be chlorine, bromine, or iodine. It's never fluorine because HF is a dangerous chemical. That's the only project in all the years I worked in the chemical industry early on in my career. I said, nope, I ain't working with this stuff ever. Do you want me to leave the company or not? They picked someone else who they could. The person almost had a nervous breakdown working with HF. It's that dangerous. But anyways, here you break the pi bond. One carbon gets the hydrogen, the other gets the halogen, and it follows Markov-Nikolsky rule, great Russian organic chemist, and I abbreviate it, M's rule. The carbon of the double bond with the most hydrogens gets the hydrogen. The other carbon double bond gets the halogen. How does that work? Oh, let's take a look. Let's have some fun. Now you know I'm an organic chemist. He's having fun doing this. He is. So if we look at this, and the question is, give the organic product or product. Well, you look for what's different, what's not a carbon-carbon single bond. Ooh, a double bond. And the rest just comes along for the ride. So I'm going to ignore it for now. What am I reacting it with? And remember, and one thing I should have pointed out, organic chemists are lazy. We can write A plus B reacts this way, or we can write it like this. And I do both. Both of these are the same reaction. A plus B react together. Well, here I have HCl, halogen, HX, where X equals chlorine, bromine, or iodine. In this case, it's chlorine. Remember, you have a pi bond that you can break, and I will. Single bond, you don't. One carbon gets H, the other gets X. Well, how do I know which to do? Well, you count the hydrogens. And notice this carbon here has one hydrogen. This carbon of the double bond has two, which is the larger number. And time's up. Hopefully I'll pick two. Therefore, first of all, I have four carbons here. So I'm going to end up with four carbons. Here are my two carbons of the double bond. The end carbon has two hydrogens. This follows Markovnikov's rule. The carbon of the double bond that has the most hydrogens gets the hydrogen. So it's going to go here. And the other one will get the halogen right there, which is this carbon. The halogen is chlorine. And there are four bonds to carbon. So I can put in my hydrogens. And that's the answer. And that's Markovnikov's rule. Now, on a ring, you've got to count hydrogens. And you look at this, and Dr. White did something mean. Oh, what do? I don't see any hydrogens. Well, you do. You just got to count them. And here are my two carbons of the double bond. And on the top carbon, how many bonds to that? 1, 2, 3, 4. 4 minus 4 is 0. So there's 0 hydrogens. On this carbon right here of the other carbon double bond, there's 1, 2, 3 bonds or lines. 4 minus 3, there's 1 hydrogen. So now we can do this problem. We have, oops, there we go. Double bond, HX, break the pi bond. One carbon gets H, the other gets X, and it follows Markovnikov's rule. And here, do you break carbon-carbon single bonds? No. So I'm still going to have the ring. I'll still have the methyl group. Now on this carbon right here, that's where the hydrogen will go. There's already 1. So 1 plus 1, there'll be 2 there. The other carbon that has 0, this one, will get the halogen, in this case, bromine. And that's how you deal with rings. One thing I should, time for a public service announcement. Public service announcement from the management me. Today is, let me check. Yep, it's Tuesday. Tomorrow, I will have my office hour from 6:30 to 7:30 on Zoom. If you have any questions, need any help, stop by. Also, I'll be posting this in my YouTube channel and sending out an email about it later tonight or tomorrow morning. Now, another example of Markovnikov addition is if you have a double bond and add H plus, that's an acid catalyst, and water. Now, you think of water as HOH. Just like HX, you have HOH, you'll learn later on, that's called a hydroxyl group, and it follows Markovnikov's rule. One of the carbons of the double bond, the one with the most hydrogens, gets the H, the other carbon gets the OH. And you can go look at the problems in the video. Now, for a triple bond, there's 2 pi bonds you can break and have fun. Now, organic chemists are lazy. I don't want to balance this equation, so what do? You look here, I have H2 bracket the letters X and S, close bracket. Ooh, what does that mean? That means excess. You've got all the hydrogen in the world to react to anything that hydrogen can react with, in this case, the 2 pi bonds. Water break. And do you break carbon-carbon single bonds? No. So here I have triple bond, excess hydrogen, and a catalyst, which can be nickel, platinum, or palladium. And each carbon now, because there's 2 pi bonds, gets 2 hydrogens. And the rest is not reacted. Now, if you have a triple bond and you react it with excess halogen gas, same thing, you break the 2 pi bonds, and each carbon of the triple bond gets 2 halogens. And I talked about how for a long time, halogenated compounds have been used as flame retardants, especially things like children's clothing, pajamas and stuff, so they don't catch fire that easy. Nothing is fireproof, but you can retard the fire greatly to make flammable things less flammable or safer. All right. Now, there's one thing I don't have in the problem set or in here, but I talked about in the lecture, so I better talk about it now. If you have more than one double bond separated by one or more carbons, each one reacts like it's alone. Again, when you have 2 double bonds, and here we have it separated by one or more carbons. If I were to say, what's the organic product of this reaction, you look at that and say, what's going on? Excess bromine? But we never saw that with a double bond. All that means is you have all the bromine in the world to react with anything bromine can react with. Well, I know I have a double bond. Bromine is a halogen, or X can be, in this case, fluorine, chlorine, bromine, or iodine. And I break the pi bond, and each carbon gets a halogen. Well, here we have 2 double bonds. You break carbon-carbon single bonds? No. So I have 1, 2, 3, 4, 5, 6 carbons. I better end up with 6 carbons. Now, these 2 N carbons with this double bond, I'll break the pi bond, and each one gets a halogen, in this case, bromine. Now, this double bond, these 2 carbons at the other end, I broke the pi bond, because that's what our general reaction shows us. And each one of those gets a halogen. And I know there are 4 bonds to carbon, so and bromine counts as a bond. And that's how you do it. Now, if it's a triple bond, there's special cases that I'm not getting into, so I won't cover that. Multiple triple bonds or a combination double triple bond. But one or more double bonds, yes, you should know this. And you'll see throughout in the problem set, I have a number of problems. This is the triple bonds in the alkenes, alkynes. And here are the double bonds. Hopefully you've practiced these. Because can you keep a secret? After test one, you'll understand why I call them practice problems. I'll say it again. Keep a secret. After test one, you'll know why I call them practice problems. Hint, hint, wink, wink, say no more. Well, that comes from Monty Python. If you've ever seen the TV program Monty Python and the Flying Circus, you're missing one of the funniest television shows ever made. All right, let's move on to aromatic compounds. And they're aromatic because they smell, come originally from molecules or things that had very strong aromas, like herbs and spices. And the first one is benzene. And benzene is a six-membered ring that has alternating single, double, single, double, single, double. You can draw it this way or this way. That's the cacula, which I think looks cool, but that's my personal opinion. Or you can draw it with the ring that shows the pi cloud. Any one of these would be correct. Now, if I were to ask you to draw the structure of benzene, and you wrote that, I'd mark 0 because that's cyclohexane. You either have to put the circle or draw the 3 double bonds. Now, this is an ancient name, and IUPAC decided we're not going to change it, and that's why it's called, the common name is the IUPAC name. Same thing for toluene. A methyl group on a benzene ring is not methylbenzene, it's called toluene. Now, for disubstitute di, meaning two things on a benzene ring, we use, instead of numbering, we use the prefixes ortho, meta, and para. Now, if you have toluene with one substituent on it, like a benzene ring, or a chlorine or other things, the methyl group counts as one group and is always number 1. All right, now, something I didn't mention earlier, besides the alkyl groups, you can have now a halogens. Cl is chloro, F is fluoro, Br bromo, I is iodo, and then a very important group, NO2, where the bond is from the nitrogen to the benzene ring. That's called the nitro group. And if we look at C, you look what's different. Ooh, a benzene ring. And what do we have on there? An ethyl and an isopropyl. Now notice they're 1,4 disubstituted. One of the groups on carbon 1, the other 4, you could have started this one, 1, 2, 3, 4. So benzene, and I follow the IUPAC ethyl isopropyl. If you put down isopropyl ethyl, I give you full credit. But 1,4 is called para. And that's how you do benzene ring. Now, if you have more than one group, use numbers. And if we look at the other type of IUPAC, metabromotoluene, toluene, I drew it this way, and I'll show you what most of you would draw in a second, maybe more than a second. We have a methyl group on a benzene ring. That's toluene. Again, go from the right to the left. Bromo means Br bromine atom. Where is it? Meta. 1, 3. Remember, oops, not here. It's on the review. Ortho 1, 2 disubstituted, meta 1, 3, para 1, 4. Now, one of the things I mentioned in the lectures, if you have say a benzene ring and something else on there, when the new group is coming on, what's on there directs it where it's going to go. And we'll do a lab with that. But since they're more important things, and I think most of you are never going to do any aromatic compound reactions the rest of your life, but you will work with carbohydrates, fats, and oils, and proteins and amino acids. I'd rather spend more time on that than something you will never use. So I won't cover in the lecture section directors. So that means the first reaction, if you have a benzene ring and react it with halogen, that's usually chlorine or bromine, and here you need a catalyst, ferric trihalide, you replace one of the hydrogens with a halogen. You don't break those double bonds, because if you do, you lose a lot of stability, and that doesn't happen. Now, let me show you one common mistake that you should not make on test one. If we look here, we say, ooh, what's different? A benzene ring. And we look here, oh, chlorine is the halogen, and ferric trichloride is the catalyst. And what happens? I replace one of the halogens, hydrogens with a halogen. In this case, it would be chlorine. So you break carbon-carbon single bonds? No. So I'm going to have the ring, but it's a benzene ring, so you still have the double bonds, and I'll replace one of the hydrogens with a chlorine. Now, the mistake is if you wrote it this way. That's chlorocyclohexane. It's missing the double bonds or the circle in there. And I had a student lose 12 points on a 105-point test because that student forgot to put that there, either a circle or double bond. To make that correct, I have to put in the bonds this way. And now Dr. White has to do something uncool, or this way. Remember, if you leave the bonds out of the cyclo, out of the ring, that's not benzene anymore. Don't. All right, next one is if you take a benzene ring and react it with nitric acid, HNO3, and sulfuric acid, H2SO4, you put a nitro group. That's not NO3, it's NO2. And because I'm not doing any substituted benzene rings, this is the only reaction with nitration I can ask you. Same thing with the next one. By the way, remember I talked about putting nitro groups on a benzene ring. You make trinitrotoluene, which is a very important explosive. The key ingredient in dynamite. And if you saw the video, you saw I talked about Alfred Nobel and how the money for all the Nobel Prizes came from his profits from his company, who sold explosives for wars. Which is nothing wrong. That's commerce. Not that wars are right. All right, next one. If you take a benzene ring and react it with sulfur trioxide and sulfuric acid, you'll put on a sulfonic acid group. Remember, don't forget the lines or bonds in the ring. And this is the only question I can ask for this reaction, because I'm not doing substituted benzene rings. Now, we'll learn later on that being able to put the sulfonic acid group, SO3H, laid the foundation to make the molecules you use in your detergent. We'll talk about that later on in the semester. And finally, Friedel-Crafts alkylation, named after two British chemists, Friedels and Crafts. And if you take a benzene ring, react it with an alkyl chloride and aluminum trihalide, you make something very special, a carbon-carbon single bond. Very rare. There's only a handful of reactions that allow you to do this, and quite important. Now, the R here means anything with carbon and hydrogens. So if we go to the problem set, let's look at E. Here I have benzene plus chlorocyclopentane, aluminum trichloride. And let's do this on the whiteboard. By the way, it's not named after me. Oh, that was a bad joke. Sorry. So let's look at this reaction. All right, what's different? Ooh, a benzene ring. And if we look here, what's different? What's not a carbon-carbon single bond or a carbon or hydrogen? Ooh, a halogen. And notice it's bonded to this ring. And that's my R group. I'm trying to think if I only gave chlorine here for our, no, I think I also, for X, normally it's chlorine, but it could be bromine. And this is Friedel-Crafts alkylation. You get the benzene ring, then you make that carbon-carbon single bond. Now, this bond right here is from the benzene ring to the carbon group in the R carbon atom that has the halogen. In this case, it doesn't, but so you have a benzene ring. Don't forget the lines or circle. Then a five-member ring. Oh, that was fun. Now, let me show you another example, what I mean by the bond from the carbon R group to the benzene ring is to the carbon, the R group that had the halogen. So if we look at this, we look for what's different. Ooh, a benzene ring. And then here, what's not carbon, what's not hydrogen, what's not a carbon-carbon single? Oh, look, a halogen on a carbon, Rx. And we have a catalyst here, aluminum halide. Doesn't matter if that's above or below the line on the arrow. And this is Friedel-Crafts. And here we're only interested in the organic, not the inorganic stuff. Yeah. So what's our R group? R is anything with carbons or hydrogens attached to the halogen. This is our R group. Everybody see that? And therefore, our general reaction says we'll have our benzene ring. Don't forget the lines or circle. Now, R has 3 carbons. Which carbon has the halogen, the center one. And that's the carbon that will be bonded to the benzene ring. And the other two carbons are coming along for a ride because you don't break carbon-carbon single bonds. And I know there are 4 bonds to carbon, so I can put in my hydrogens. And we've just made isopropyl benzene. But remember, in Friedel-Crafts, alkylation, like all aromatic compounds, don't forget to put the bonds inside the ring. And the bond from the benzene ring goes to the carbon. And let me use a red pen to show you that. Goes to the carbon with the halogen. If you put it on the end carbon, I'd mark it wrong and give you 0 points. So placement, where you put things in a molecule are important. With that, I'm done for the evening. I'm going to stick around a couple of minutes. If anybody who's here has any questions, I'll turn off the recording and answer them. And I will be posting this video either later today or tomorrow on a YouTube channel. I'll send out an email and I'll post an announcement where it is. Don't forget, Thursday will be test number 1. Do the practice problems. You'll be in good shape. I also sent out an announcement about my test anxiety video. If you get real nervous during a test, watch that video. I developed it many years ago. Watch the video. I tell why I developed it. And it's helped students go from D's and F's to A's and B's. You still have to study and do the practice problem. With that, like I said, I'm going to say goodbye for the video, but anybody who came has any last minute questions, I'll stick around. With that, you know what I'm going to do. I'm going to say "Gang gesund," which is Yiddish for go in hell. And by now, I've still there from Granting to Beverly Hillbillies. Bye.